Hello, hello, hello. Greetings. Just checking, make sure everything seems to be working. Excellent. Okay, so let me check the stream. And good, I'm on screen. Good. Excellent. All right, so I'm going to do a little bit of droid building. I don't know how long I'll be streaming. It's been a while since I've done any. But I thought I would kind of go over some stuff here before I get started, just to get my head back into it. So this is Fusion 360 if you don't know, and what you're looking at is the wheel of a mouse droid. Specifically, this project is my mouse droid modifications, or at least for the chassis, it's the modifications. And even more specifically, it's the modifications for the front steering system. So right now you're looking at essentially the default that comes with Michael Badley's model. I'm just spinning it around because I got a fidget. But we have the wheel here, the tire, and then we have the actual wheel. And then you have this axle block here. So let me turn these off. All right. So this is the right hand axle on the front. Let me turn on the frame so you can see that. Turn the. Uh-oh. Dropping frames. Check OBS. No? Looks fine on OBS. I don't know. Alright. Okie dokie. Anyway, where was I? Alright, so this is the front frame that attaches the two front wheels. So there's one on that side, one here. Two axle blocks. The axle block has a 683 bearing, I believe, by default, that goes in these two holes, and then there's the two holes on the opposite sides from there. There we go. Okay. So 4 683 bearings. All right. And then if I take away this frame, you'll see there's two holes here on the top. Right there. And those by default just get screws. They go through this frame. There's 683 bearings in here and in the bottom. Right there. And then through the screws you just get screws through the bearings and directly into the plastic of those two holes there, one on the top and one on the bottom. Now I've upgraded this. The other thing I should point out is that by default, M3 screws is a 2.8 millimeter diameter hole, which you can't really see because my model's in the way. Let's see if I can move this out of the way or hide myself. Can you see it? Does not look like it is actually being displayed. Doesn't matter then. I'll just put myself back on. Not that I actually disappeared from your view, but I did in mine. So you'll have to take my word for it that this hole is 2.8 millimeters in diameter. And then you just get an M3 screw into it. Everything seems to be fine. So just keeping an eye on OBS over there. So anyway, an M3 bolt goes through this, through the bearings, out the side, and then has a lock nut on the end. And that holds the wheel onto this block. And then this arm that sticks out the back here, like that. Another wheel that's visible for some reason. Where is that? It shouldn't be visible. Oh, because I turned on the rear outer wheel. That's dumb. There we go. I turned on the wrong one. Okay, so in any case, M3 bolt goes through here, through the bearings, through here, lock nut, and then these two arms, one on this side, one on the other side, have a bar that connects them and a servo that kind of pushes the bar back and forth, which causes the tire to rotate, or the wheel to rotate. All right. So the problem with this setup, there's a couple actually, and that's the goal of my modifications. The problem is that this bolt that goes through the wheels is 3 millimeters, and that means it gets bent very easily. If you crash and or you hit a bump too hard, it can bend that bolt and your axle's bent and then your wheel wobbles. So that's one issue that I planned to solve. Another is that the distance from the bearing to the hole here is 8 millimeters, right? And actually it's a little less, I think, because it sinks down into the bearing. There's a M3 countersunk screw that goes into this bearing that sits in that hole and then threads into this plastic, right? Except the screw that's called for is 10 millimeters. So there's only at most 2 millimeters biting into this block. And the same thing happens on the bottom from here to there. Fusion is showing that that's 8 millimeters between those two planes. I found in practice that a 10 millimeter screw is not enough here. I needed at least 12 to keep these in at all, especially the lower set here and on the other side. I needed at least a 12 millimeter screw to actually reach this block and thread into it with any hope of keeping the screw in. I didn't actually like the setup, and I've lost screws and bearings multiple times just from vibration, because the connection between those two is so minor. So that's the other main issue that I wanted to upgrade. So I'm going to walk through the changes that I've made just because I can. Okay, so the OBS thing on my Stream Deck is claiming that there are more drop frames, but OBS itself is not. It doesn't see any, so I'm not sure what's going on there. In any case, continuing on. Okay, we have where was I? Okay, stepping through the various changes that I made. All right, so I got a couple changes here to increase sizes. Another issue with this setup is that I've heard from others that the frame breaks very easily. I haven't actually experienced this myself, so I don't know. I'm strengthening it in the process of doing this modification, because I have to change this part regardless. So we'll see what those changes entail. So the first one is to thicken the arms. And if we wait a moment, because Fusion is being very slow today. We're thickening the block, so we made the block back. Come on, go back. Okay, yeah, so we made it wider. You see, currently it's thin. I made it wider. I needed that to accommodate some things that I'm doing. Then we're thickening the arms. So you see that these arms right here, up and down, they got thicker. That's to increase the strength also along this bottom edge. Make it less likely for this thing to break. Like so. Next, I'll set some faces. Which faces? I'm not sure. Oh, okay. I'm offsetting these faces here. I'm making the recess for the bearing deeper, and that lets the screw sit closer to the thing, and you'll see why in a minute. All right, I'm widening this gap between these two arms, which actually bends the arms out again, but that's okay. I think I'll fix it maybe later. Right, because I need to make this thing thicker, the axle block, or as I call it, the new front axle right. All right, next is increase the bearing diameter of, adjust the steer bar position. All right, so let's look here. I think I'm basically shifting. Oh, I know what it is. I'm not showing the part. Here's the steer bar. This is the bar that connects the two steering blocks. Come on, Fusion. Behave yourself. All right. So, as I adjust the heights, I need to adjust this thing. And that's what that one does. All right. Then next we have the bearing diameter. Specifically, I believe this bearing and the one on the other side. What I'm planning to do here is, or the purpose of this is to increase that M3 bolt to an M4 bolt, which is 30% thicker and therefore a lot stronger. 30% greater in diameter. Right, so next is increasing the diameter to accommodate that. It was previously, I believe, 7.2. Come on. 7.2. Yeah, 7.2 millimeters, 3.6 millimeters radius. And I've increased it to 5.3 millimeters radius, or 10.6. I leave it that way. Yeah, 10.6. That is a MR104 double Z bearing, or just a 104 double Z bearing. That is what I'm using on these. That has it's a 4 millimeter, I believe, thick, 10 millimeter diameter, and 4 millimeter inner diameter bearing. Okay, so next we are, we're going to hide the bar in the frame for the moment. Okay, so I'm increasing the bearing depth to accommodate the new bearing. Yep. So it is now 4 millimeters. I believe it was a 3 millimeters for the 683 bearing like this one. And now it is 4. And then I'm opening these holes because what I'm doing, instead of threading a screw directly into this plastic, is I'm inserting heat set inserts. The brass inserts that you melt in there with a soldering iron. And then I didn't even name this one. What is this one? Increase it further. That's great. Why did I just combine those? I don't know. Let's edit the feature and look and see how much I changed it. Negative 0.3 millimeters. I'll fix that now. You can't see the window popping up here at my cursor. So if I make this -1, and then I get rid of the other thing, gotta wait on Fusion. I got a lot running, so Fusion is a little slow. All right, let's suppress this one. Actually, let's not suppress that one. That's why I didn't do it. Fusion has this really annoying thing of locking features to something that doesn't matter. So when I unsuppress this, some other things look like they got locked. maybe they didn't. Maybe it was just my imagination, but I have run into that before. All right, so I don't want that at this. Maybe I'll suppress that and change this one. That sounds like a good idea. -1. 1. There we go. So they should end up being 2.4 or in radius or 4.8 in diameter. Okay, I think I do actually increase that later. Somewhere down here somewhere. But we'll look. All right. So this one, you also, I don't think can see, no, you can't see it on the stream. There's a little pop-up when I hover over these things that tells me what they are. So this one, I basically took that hole for the threaded insert and I made it go all the way through. The reason I did that is because I wanted as much space for screws to go through as possible. I mean, there's going to be a M4 bolt going through the middle here with as an axle, but up to that point, you could pretty much put screws. You know, as long as there's a little gap between them, should be fine. All right. Everything seems okay. Cool. Gotten a couple more allegedly dropped frames. Don't care about that too much. All right, I'm gonna look in here and see if this is active. That's not active. Okay, this whole little group right here is suppressed. So we're gonna skip over it. I believe, yeah. At one point, I had a version of this where I was using a lock nut to capture or try to capture these screws, I think. I could delete that, it doesn't matter. I'm not doing that anymore. Boom, boom, boom. Let's nope. Let's go one by one, thanks. Here's a big group right here. Why am I in the middle of it? I don't know. All right, so next thing I do is I make a sketch for the wheel hubs. So I need to turn the wheel hubs on. All right. As part of this process of fixing the axle block, I also need to fix the wheels because this is, again, an M3 space. I need an M4 space, so I need these holes, these 3 screw holes that go on the outside. I need those further out from the center. So and this hole to be larger. That way, I will have space for the M4 screws, or M4 axle. So, I created a sketch. Which one is it? It is, find it. It's a very good question because I don't see it on here. Allegedly, it's visible. In practice, I do not see the sketch. Why not? Okay. That's very bizarre. Fusion, what are you doing? What are you doing to me? Is the sketch suppressed somehow? No, Fusion just doesn't know where I am in the history. Okay, that's cool. All right, let's look at the sketch. All right, there we go. So this is a 4.7 millimeter diameter hole, or sketch hole, so circle to make a hole, in order to make space for that screw, the axle bolt. And then I have, if I hide the actual wheels, like so, you can see I have space for screws. This one is the old screw diameter. This one is the new one. And that's what we have. Okay. All right, so we're just basically making changes to the wheels. Let me open the wheel. Think. And this is the result. So you can see the new holes on the wheel line up. I'll scroll back and see. So there they are. I fill them in. I push something. What did I do with this? Offset faces. I went back too far. Okay, and then put offset. Filling it in, I think. Yeah, that's a weird way of doing it. I don't know why that happened. But what I did there was just basically push the face back to where it should be. All right, I cut the hole for the axle. Cut the hole for the screws. Sorry, cut the holes for the M3 size screws. Right. Oh, that's what it is. When I was putting these together the original way, I found that these 3 screws around it were very, very tight and very hard to put in. So I decided to widen the holes a bit, make it a little easier. That may be because my printer's calibration's a little wonky, and holes tend to print very closed up sometimes if they're small enough. So I widened out these holes a bit. On the inner side here, it doesn't matter too much. Oh, yeah, that's what's going on. I see. It's been a while since I've done some of this work. Let me find the analysis here. All right. So this is a cross section. So what I did with these 2 circles is one is a space to let the screw go in easily, and the other is the actual hole that it threads into. So I found it was very tight to have the entire thing be the size of this hole. So I made a larger circle in the outer section, and therefore I could put the screw in a little bit easier. I think I do actually make it a bit bigger. I'm not sure if that's what I did here. Let me go back to the original screws and we'll find out. So you see they're countersunk. 1.4, no, so 2.8 is the original diameter. May or may not have changed that at some point. All right. So there you go. And then I do the countersinking. Okay. And that creates that cone shape hole. I can hide the sketch now. It's kind of annoying me. Cone shape hole right here for these 3 screws with a fillet. Oh, sorry, chamfer, not a fillet. All right. And then I offset the inside screw because this screw, this axle bolt, is bigger. It has a larger head. So I decided to inset that chamfer a bit to make the screw sit better in this little fake hex nut on the outside of the wheel. There it is. You can see. I go back. It's just a larger hole. All right, so that's that. Sketches go away. All right, now a lot of this stuff here going off behind my model, a lot of this is just loading in hardware, CAD hardware like screws and bearings. So you'll see those. I'm going to add them in. So this one, I moved the wheel out a little bit. Let me get analysis back and turn on the axle again. All right, so we can see what's going on. All right, so I've loaded 3 screws and a washer. Or no, just washers. Yeah, I've loaded washers. Michael's build of this, or design for this, calls for M3 washers. Of course, I'm going to M4 washers because I have M4 axle. And I don't need as many of them, I think, because M4 washers are a little thicker. But I have offset this. See where it goes. I believe this goes this way. Time to hydrate. Oh yeah, so it's sitting a lot closer there. So I just move it and then put in the washers. All right, and then we got lock nut. That's the lock nut that goes on the other end, I do believe. Ball bearing is. We'll just load a bunch of this stuff in. We can figure out if anything else is important. All right. So we have the hardware in here. Let's make it visible. All right, we got the lock nut. There it is. It sits on the end of this screw. There should also be another washer somewhere. Here it is. All right. I need the screw. Yeah, there you are. So there's the M4 bolt in place. This one is 50 millimeters. You can go up to 55 if you need to hold these things on. Of course, if you don't use a countersunk screw or bolt, then the length is going to be larger. The necessary length is going to be larger because a countersunk bolt is measured from the top of the from here, whereas most bolts are measured from where the threads begin. All right, so a countersunk bolt is going to be a little shorter than the equivalent of like a socket cap screw or something like that. But in any case, there's the bolt. We got bearing here. This is the 104 bearing. This is the other 104 bearing. So those hold the axle in place and let the wheel turn. Of course, it's a front wheel, so it's not driven at all. Yeah. Let's see. All right. We still have 683 bearings on here and here. So that's what these are. Right? They sit a little deeper. The other reason why I made this recess deeper is so that the screw would sit down in here a little bit, and it keeps the screw from hitting this wheel. Not that it was a big problem, but I just figured I could do it. I have the space, so why not? Here's the heat set inserts right there. They go in those holes. And then there's the screw that goes into the bearing. Here's the other one. And the way this works is I have 18 millimeter screws. Sorry. I think 12 is the minimum height of this screw right here. Now, because I made those adjustments, currently the distance from this arm, actually I should go from the bearing, shouldn't I? Bearing to there is 7 millimeters. All right. And then you need a couple of millimeters inside the heat set insert. 5 should be good. All right. I think this is not strictly accurate, but we'll see. I'm using 16 millimeter bearings. They may be too long. Not bearings, screws. here. So yeah, remember, countersunk screw is measured from the top, not from the section where it intersects this bearing. So from there, it's 7.7 millimeters, but from here to there, it's almost 9.3. All right. So I think an 18 millimeter bolt is probably the maximum. You're getting close to hitting the axle. A 12 is probably minimum because, like I said, from there to there is 9.3, and a 10 millimeter bolt would just barely be threading in here. So you want at least 12. 16 is probably best, and that's what I'm going to use. And 18 is probably the maximum. And of course, it's longer if you're not using hardware again. All right. But the way this works is these two bolts right on these bearings, and so this whole assembly can turn around those two screws or two bolts. Got it? No advertising, please. Right. So, continuing on, we got all the hardware in here. I just have one more screw, which is the example screw for this. I believe this one is 8 millimeters. Is that right? Yep. So this is a 8 millimeter M3 countersunk screw, bolt, whatever. You could probably go to 10 if you want, but 8's probably fine. Actually, 10 might stick out just a bit. I don't think they actually quite sit as sunk in here as this would suggest. Possibly the heads are a little wider than this particular screw, but that's this. I need to like get this zoomed in better because hello, Fusion. Would you like to work? Anytime now. Okay, thank you. It's not wanting to work. We're going to do this. There we go. Okay, we flip around here. Got it. All right. Sit up here. Posture. So this is the basic structure of the M4 mod. You've got the thicker axle, you get the longer screws, you get the heat set insert, and you got a larger bearing here, wider spacing on these screws, etc. The bearings here are not changed. They're still 683 bearings. And the bearings on the pivots here, these bearings, those are not changed either. So you just continue to use the same bearings for those two. It's just these two bearings, the longer thing, the longer screws here, and the new parts. All right. Now, I did make some tweaks after this. I think this was how I originally had it, but I've made some tweaks since then. Mostly for tolerance on my printer. But we'll see. So I did this, which was to increase the 683 ZZ hole. So this is the holes on the steering arms. I did slightly increase the size, make the bearing fit better, because I had a lot of trouble getting the bearings in. Did the same thing on these for the same reason, because it was the same. Actually, they weren't the same size for some reason, but I fixed it. All right, this there's a sacrificial layer in this part. Basically, you can see that this is sealed like that. That's just to make it print well. So you can do it like this. So there's no like bridging for this lip right here that the bearing sits on. You don't have to do weird curved bridging and it droops down and all that stuff. You have this solid layer. I gotta flip around here. All right. So all I did was make that. I say, oh, I made it thinner. I found it was rather thick at like 1.2 millimeters or something. I don't know. Maybe it's 0.6. But I made it 0.4 millimeters thick, which seems to be just fine. All right. I shifted, I believe, the wheels outward. I don't think the hardware went with it, but we'll see. Depends on if the joints are set up correctly. All right. What did I move here? Oh, yeah. Oh, no. Okay, I see what it was. Yeah, let me get the tire. Front tire. Before I move this tire, the wheel was slightly offset, probably from where I moved it back here. Did I move it back here? Let's check. All right, Fusion does not store the amount that you moved apart, which is really dumb. All right. But in any case, I moved it, so now they line up properly. All right, continuing on, we have the offset there. I made this hole a little wider again. I mentioned earlier, I found that they were a little hard to put the screws in, so not only did I make this hole wider, I also made this hole wider, just not by the same amount. Or name that part. Offset wheel screw holes, just so I know what I did there. Next, another offset. Which one was it? Now they are the same size. Probably should have just offset them all at once, but I did this part much later than the rest. Rename offset inner wheel screw holes. Sure. There you go. Good enough. Okay, next. I also was apparently lazy and didn't name any of this stuff right here. Okay, I made these holes wider. I thought I did. They're 5 millimeters now, I do believe. Yes. So these holes through here are now 5 millimeters. After checking the tolerance on the print, this seemed to work pretty well for just putting the inserts in, letting them rest in that hole. Then you can insert them. So rename, make insert holes 5 millimeters. Okay. All right. I think that's the bulk of the major changes. I did do 2 minor changes. Well, really just one minor change. It's just two features. Basically, I made this part stronger by putting some fillets in here, like that. There's space for this stuff. These two parts don't come into contact. So I figured instead of having this stick out in a corner like that and like that, why not just fillet that and make them a little stronger? So I did. So that's what's going on with this. I can turn off section analysis, and you can see this is the final bit here. So there you go. So when the servo moves this bar back and forth, left to right, it turns these around these screws. So the wheel, the bar comes this way, the wheel goes that way, and vice versa. And then, of course, the wheel can spin around this bolt. And that's the front wheel. Now, that's basically what's going on with the modifications. I'll probably release this when I have a chance to get my new hardware in, the M3 bolt, M4 bolt, and the new screws. I already got the bearings, heat set inserts, and all that stuff. I just need the actual fasteners to test it. So we'll see how that goes. Yeah, I think I went with longer screws. The distance between here and here is 9 millimeters. This is a 50 millimeter axle, so almost 10 millimeter difference there. If you went for a 6 millimeter axle, you'd probably hit this, but a 55 should work just fine. And I do that because I don't know some of the tolerances on this, like I don't actually have the washers to measure them. I just know what they theoretically usually are. This particular washer is 0.6 millimeters. However, I've measured them higher than that. So it could push this out a bit. Also, depending on how clean your holes are, the bearings might not sit all the way in. So things like that will affect how far out this lock nut sits. And that will cause, the screw to be, need to be a little bit longer. Maybe not the full 5 millimeters, but that's okay. Let's look here. Bing. All right. Interesting. All right, I was checking something on the stream. That's all good. So that's the mouse droid modifications. I just wanted to kind of go over those a bit. But that's not what actually I'm planning to work on, because it's, as you can see, it's mostly finished. When you save this version, or I've renamed these things and tweak some things. Hydrate. What I'm actually going to work on is different. Let me bring up my image if I can find it. Yeah, here we go. All right. Make him a little bigger. And shift him over a bit. And you can't see it yet because I haven't actually sent it. Turn OBS. Calm down. Wow, there you go. Okay, so this is one of the concept pieces for Dio. If you saw Rise of Skywalker, this is Dio, the little green wheel droid that has the cone-shaped head. So this is one of Luke Fisher's concept sketches. I have previously done a let me find it here. I'm going to hide that and turn on this. All right, so I previously built this droid, which is also a concept sketch for Dio by Luke Fisher. Move it over here, and there we go. I can see it. So I did this one. It doesn't actually lift its head, as you can see on the left. I keep moving my cursor over OBS like you can see that. But, so the one on the left, I did actually design a way to do that, but I couldn't fit a motor in there that would actually mechanize it. And it made stuff like changing the battery a little awkward. So I redesigned it, and now the head is static, as you can see in the image on the right. If you saw the slideshow at the beginning of the stream, then you would have seen pictures of this droid. So, all right, let me go back and find that image again and swap it out. There we go, and I gotta move it again over here. Put it on the far left somewhere. All right, and send that like there. Okay, so what I'm actually going to work on is that. Let me close this project, and you can see where I am. Actually, yeah, you can see where I am. Waiting on Fusion to catch up. Any day. Okay, there we go. Finally. Now this one started out as a Michael Badley project as well. This is the DO project. It's just the normal. Let me turn off some of this stuff, and you'll see what I'm talking about. We got all this stuff in here. Some of it is turned off. There's this head. Skins. Okay, this, that. Cool. Part of it is missing. It'll be these. I'm not sure why they're black. Oh, that's not because they're not the. That's not part of it. Okay. Inserts. Sure, we'll turn those on, don't turn that on. Neck, panel. That's mine. Not sure what's there. These are okay, modified parts. Pink. Okay, well, you can kind of see some of it. Mine cover this stuff up. Got it. Turn this one off. And yeah, you kind of see that's kind of DO. There's part of it that's not on. Part. That part and that part. I changed the color, I think. Yeah, so you see there's DO's head. His wheels and his antenna. My bits are a bit different. Starboard? No. Okay. You can see the idea. All right, so I'm going to turn off all that stuff now. Turn that off. Turn that off. Tire. I'm sure some of that was not actually the accurate parts for DO. Just random stuff I have here. But gives you the idea. So I'm building this around the existing project to do the new concept version of I guess DO. I'm calling him D83, but whatever. So you can see he's got his head up here. And if you look at the reference picture, You can see he's got the little lens things there. He's got the panel lines and the vent in the back. Got the little door thing on the top, which is also on the other version that I've already done. Panel on the thing here. I don't have these little details. I can't point at them over on the picture over there, but on the slanted edge on the bottom, there are some details I haven't put in yet. I haven't put in the main lens yet. I do have this bar. I do have these details. Currently the same on both sides, but I have sketches for other stuff. Let's see, face details. No, we want the cover details, side details there. That one. All right, so these little top details on the wheel over here, you can see to the left of my cursor. On that picture, there's a little blue button detail and some bits. I'm going to have to actually pull up that image myself so I can look at it, because I can't see it on the OBS screen very clearly. It is not there. Of course not. So I renamed the file. All right. So yeah, so there's like the horizontal, the sort of badge shaped panel on the bottom with the 3 insets on it, and then you got the stripy bits above and below, and then the blue round disc thing. Those need to be done. I did at one point do a version of these little panels on the orange rim of the wheel, so that's a thought I need to do. I need to do the details on that slanted edge. Slanted edge on the orange face sections. So up here and down here. And then this whole thing needs like some fillets around it. So like that, I've already done some of them. So round off a lot of these edges. I did have to invent details, so invented the backs of these vents right here and here. Actually, I invented this entire vent because you can't see it in the picture. All right. So now what I need to actually work on is some of this stuff. Ouch. Scratch my ear. Okay. All right. Face. All right. So the way that this is designed, I have dropped some frames now. This claims I've dropped 975 frames. I don't know when that happened. We'll see. All right, so I zoom in here and look at my image. All right, if you look at the reference image on the top of the main eye, you can see that it kind of blends in with the top slant bit. At the top of the lens, like the little surround, or the silver surround around the lens itself. That is kind of blended into the body of the droid, whereas the bottom lens, there's a gap between the silver bit and the, I guess, the flat round bit. I'm basically to the left of this, to the left of that. All right, so there's that. I don't think I need to actually design in any lenses for this. I know they show lenses on there, but I would probably And I really need to check the diameters of these circles. I would probably use the lenses from Googly Eyes. You cut the plastic lenses off of them and paint the inside of the lens black, and then you get something that looks a lot like those little small lenses in these positions. And then I would just glue them into these spaces. All right. Now, one thing I do plan to do, which I'll have to turn off some of these bits so you can see what's going on. It's a sketch. That's the one for the details. Okay. Turn off the center of the head. These two features here, these two shell features, basically hollowing out the inside of these bits, those two side sections. These, I'm not sure how I want to do it. The way I designed LDF1, which is the other version, let's see if I can find OBS now. Images. LDF1 is this droid. That is there. He's in the wrong place. I really should just import these images. Why don't I do that? That'd probably be a good idea. Instead of using that, then I can look at them. Do I have this already? Sorry, I had to sneeze. Okay. This droid. Let me shrink him down a bit. And put him over there. Okay, that droid. And then add the other one as well. Existing. You. So I need to rename this one. It's currently just called droid, which is not very helpful. All right, so you need to be shrunk down a bit. All right, we're going to put him there. So I can do side by side. Position. All right, now you can see them both. I still can't point at them because my cursor gets hidden behind the picture. Yeah. All right, so you can kind of see the similarities here, I think. Let me go into turn off studio mode so I can see what's going on. All right. So LDF1, the droid on the right, is the tracked version. You can see the head similarities. And well, the way I designed it was that those white sections of the head are, let's say, they're attached via magnets. At least the one on the left, the one on the droid's left or port side is attached via magnets. And also screws. It's held on permanently by screws, but it's just magnets to put it in place and align it. The one on the starboard side white section is actually just part of the same part, I believe. I remember how I designed that. Yeah. So the entire starboard section from the orange part all the way over to the edge, that is one piece. It's a little awkward to work in, to be honest. So I may or may not design this one. Let me turn these off. May or may not design this one to be a little. Actually, let's leave this one on. A little easier. Let's see. I'm thinking. So what I'm planning to do with this droid, I'm not going to have a complicated head mechanism like I have with LDF1. Pink. His head can nod up and down, it can turn left and right, and it can tilt left and right. So we have all three axes: roll, pitch, bank. On this droid, I'm only planning to have the nod axis up and down, so basically turning this way, and also this arm should be able to move forward and back. So essentially the droid can lean his head forward or lean it back, and he can also look higher or lower, but he can't rotate his head. Instead, the whole body can just rotate, and he can't tilt his head, of course. DO can actually do the head tilt. I don't think DO can do rotation. Wait, maybe he can't. I'd have to think about it. Where's his head at? Headbox, head, and neck. Yes, he can do rotation. Okay, so let's turn this stuff up. Yeah, so DO's got a servo here for rotation. And then he's got nodding, because this bit can turn up and down using this tie rod here, so it kind of stays level, to be honest, if I remember correctly. Like, if his arm goes forward, then his head will stay level. But there is a servo in here right there for tilting, so going this way and this way. And yeah, that's right. Okay, so this bit can actually go up and down on some versions of this mechanism. I don't think this current one does it. I don't actually have DO built. I'm trying to remember how he works. All right, going back into this nonsense. And the arm is here. I need to rename this part. Main arm. I did think about designing this so that the head can actually raise and lower on this arm, because this thing kind of looks like it has a sort of a ladder type of thing, like it goes up and down, like a cover over something that slides up and down. But honestly, this head needs to be as lightweight as possible, and putting that mechanism in there would be a pain. So I'm not going to do it. My little ladder thing does go up too high because I need to put a rotation in here. But what I'm planning to do is attach a servo essentially directly between this arm and this section of the head, so that the entire head rotates up and down. So that's kind of what I'm doing there. If curious, I have not actually hollowed out this middle section yet. I'm going to have to probably soon, before I put the hole for the eye in here. So I don't know. Let me drink. All right. Why are you here? It's interesting. I don't know. I'm actually going to look at the Twitch page and look and see. What are you showing? Why? Interesting. I don't know why. All right. Doesn't matter. Continuing on. Fusion. There you are. Yes, there you are. All right. Thinking. Let's see what I want to do here. So I need to connect those two. Honestly, I might need the head to be slightly further to the starboard side, this side, over here. Don't necessarily have to. I could put like post or something along those lines. One thing I do need to deal with at some point is the fact that this tire is solid. Dio's tire is not solid. Got to find the things. Find the things. Dio's tire should not be solid. Where's my tire? Off all this stuff. Turn this on. Turn off the tire. Turn off that. Okay, it's not supposed to be solid. You can see it there. I'll apply a different texture to it so it can actually be seen. How about this? There we go. Now you can see it. Okay, what it's supposed to do is be hollow and collapse as the weight of the droid goes on the bottom. And I need turn this off, turn this off, turn this off. Don't turn that off. Now we wait. Ding. Any day now, Fusion. So, there we go. Okay, the way that Dio works is that there are actually the real tires are on the edges of this one. So it's not that one. Not that one. Maybe another one, but there's a little ring that sits raised right there, and then another one over here, and it works like a tank. So, you know, one wheel rotates forward and the other rotates backwards, then the droid will spin in place. Or turn if it's, you know, one goes slower than the other. Then it'll like steer like that. Okay. So, but the upshot is that this fake tire in the middle needs to collapse. Needs to be hollow. I'm not sure I'm actually using the current version of this project. It's hard to say sometimes. I was looking for a version that had... this one did not use servos. That's what that was the thing. I didn't want to use continuous rotation servos. I wanted to use actual motors like those. So, right. Where am I? Panel port, cover port, all that. Get out of the way. And that thing too. Where am I now? Let's just turn that off. All right. Panel starboard. Lower button starboard. There we go. So here's the head and the arm. Now we need to work on the face, I think. And also maybe this mechanism. I don't know. We'll see. So, I'm going to back away from all these fillets and hauling because I need to design the things here. Now, I did plan did consider, I guess, using the same eye as in LDF1. I thought it would be interesting to make them the same exact part. But I don't know that I'm going to do that because I think the one on D83 needs to be larger in diameter. I could go check. Let's see. I'm hesitant to make Fusion even be slow again, but LDF1, find your head. As you can see, the project on April 25th of 2020. However, I didn't actually build the droid or do most of the work until 2022. Start in the summer, kind of. I did some drafts and concept sketches and stuff before. All right, so this is LDF1's project. You can see the arms where I was designing that lift mechanism. Hide D83's picture. Okay. Picking up some cars, something outside. But you can see he has the same. Let me move him slightly to the right here. Off the side there, buddy. Make it a bit bigger. Okie dokie. Drop frames are still fine. All right. So let me lock this source. Thanks. All right. Okay, so LDF1 has the same sort of door, same sort of eye, and all that junk. The diameter of this surround is a little bit more than 64 millimeters. And then the eye itself, the lens is 50.8 millimeters. Whereas on D83, so I got these sketches here. Let me hide the bodies, so to speak. All right, so the actual lens would be 61.9, and the orange bits of his head, which I need to bring back as a sketch. Let me make him bigger. It's right off the top of the screen. This needs to be lower than my title, doesn't it? Ding ding. Okay. Fix that. All right. So the orange bit, the outermost orange bit, I think I need to lower it slightly. We're gonna look at it head on here. So this is the upper slant bit, and this is the lower slant bit. You can see I've got some of the details sort of sketched in, but I haven't actually done anything with them yet. All right, so the lens probably I was trying to decide. I think what I need to do is make this circle larger and use it to create the bottom rounded section on the face, because that needs a large radius. Or maybe I just need another circle. I definitely need to lower it. So currently the center of the circle should be right there, where the should be right here. So if I lower this distance, which is on the main sketch of the face, right? X5, it is I large offset. You can't see the parameter window. This is because Fusion is annoying, by the way. All this stuff that you can't see, like the pop-ups over these features down here at the bottom, or the browser on the left. Behind my droid. On the left, right in here. Can you even see my cursor now? Oh, I gotta do this. Okay. On the left over here is the browser, which shows me the various parts and sketches and things. You can't see that. You can't see this parameter window that I'm dragging around. You can't see pop-ups. It's kind of an annoying way for Fusion to work, but it's the way it works, so whatever. The parameter window. I said the eye offset. Eye large offset vertical or _V. Close this window. Yeah, you can you see that pop up? No, you can't. Okay. Can't see that either. It's kind of useless unless I do display capture. But I don't like doing that because, I might leak something. Fusion, give me the parameter window back. Parameter window, not that. All right. Eye offset is 5 millimeters currently. If I lower that to like 2, then the circle should move downwards. Bonk. Like so. Now if I bring the droid back, there we go. That kind of looks, I'd say, aside from the fact that looks like it's chamfered, it kind of looks like it's the right size. Maybe stand to be a little lower. All right, let's change it a little lower while we wait for Fusion. All right, large offset diameter 1 millimeter. Okay, that seems about right, I think. I'm looking at the concept sketch and let's see if we can find my cursor. There it is. Okay. Directly to the left on the underside of the face where it slants downward, I'm looking at how wide that curve section is. And this seems close. It could probably stand to be a little wider, but there's diminishing returns because I have to actually chamfer it too. And I don't want that chamfer to be so large that it interferes with those details on this face here. All right. Now, the circle is defining that lower edge, however, not defining this. You could say it's defining it. It's not hard geometry, it's just I'm trying to figure out how I want to do it. This is not strictly speaking the offset of the large eye. This is strictly speaking the offset of this curve right here. Is that affecting on the front? Let's see. And we wait, and we wait. We're minimizing this picture while we're waiting. Hello? Interesting. Okay, fusion. All right, so it doesn't affect this. I'm going to close LDF1's head because, yeah, fusion being slow. All right, so I don't want this edge chamfered down here to interfere with these details like this and this. So that's a problem I have to be careful about. I suppose those details don't have to be there. Bit sleepy. I did not sleep very well again. Looking at this sketch, or this illustration rather, it's not a sketch. Sketch is the fusion bit. All right, I'm zooming around in my sketch here. Sketch again. I called it a sketch. Okay, it does kind of go larger. Does look like the bottom curve is thinner. Like it's not as wide as the top curve. So this intersection here. Let me these details. Nope, I want face. I think. All right, so I'm gonna put a dot there and intersect with this pink. So I'm constraining it to this horizontal line, and it's already constrained to the curve, so they match up. Good. Do the same thing up here. Put a coincident thing there. I should probably not have the droid covering the whole thing here. I can shrink him back down. Shrink you so we can actually see what's going on. All right. Okay, so this dot is constrained to the circle and to the line here. And it is, in fact, a bit wider on the top than the one on the bottom is. There. All right. It turns slightly. All right. I think I should have some music. Let me go find this. Okay, this one. I'm gonna listen to the Subnautica soundtrack. I don't believe that will appear on the VOD, so you won't be hearing it. Let me make the quality a little lower for bandwidth reasons. All right. probably turn it down a bit. You look at my volumes. Turn it down a little bit. There we go. Hopefully it's not too quiet. Don't have an easy way to monitor it without playing the stream. All right, OBS, come back. Acknowledging that. Okay, thanks. 83%. Wow. All right. So I'm thinking this gap between there and there needs to be smaller. Here, look at the picture again. Yeah, there's not a lot of gap there. So it needs to be a little bit smaller. And also, the gap between there and there could be right. It makes the entire thing shorter. But I think I finally found a good balance between the sizes, so I don't really want to do that. Working from concept art is always fun. You get to invent details, and sometimes you have to invent details, and sometimes you have to just kind of judge things. All right. So if I increase the diameter of this slightly and move it up slightly, kind of weird though. Like on sketch, on the concept, need to stop saying sketch for that. On the concept, the circle would define the actual contour of the cone, the sort of chamfery shape. On the lower part, down here, it would define the flat face of it. You know, this surface. So that makes me say that the eye is actually offset upwards from the center of this circle here, which makes sense. It's fine. All right, let me go into the sketch again. All right, so this one is 81.9 millimeters in diameter, which is eye large cutout diameter, eye large body outset. So weird way of doing it. Look at my parameters. Over here, large cutout diameter, 61.9, so it's a 20 millimeter difference. Yeah, large body outset. Okay, so I'm defining this as a 61 millimeter circle, which is that other circle, I'm pretty sure. This one. Yeah, 61.9 millimeters. And then this is 20 millimeters larger. Dun, 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 dun. How long have I been running? An hour and a half. All right. Hello. Thinking. Let me rest my voice a bit. All right. So I think if this is slightly higher, I can change that. Yes. That's the offset that I changed before. It was 2 millimeters, so I should have left it where it was. Large. Offset 2. Could go up eventually. Fusion. Hello. There we go. Ah, so this attached to that as well. Oi. I don't want that to attach to that. I'm not in the sketch. Not in the sketch. Why am I not in the sketch? Okay. All right, go back to the detail sketch. Base details. Aha. You. Delete. Hello? Delete. Thank you. Okay, so those are different. You. I don't want you centered on this thing. Like that. Why are you different? Not supposed to be a different size. What did you change? There we go. Alright, you're supposed to be 6 millimeters. You're supposed to be 6 millimeters. And you. Why are you. What is defining you? What are the dimensions of this set somewhere? Let me hide the other sketch. Interesting. I said let me hide the other sketch. Stop it. Okay. I'm looking. Define that as 6 millimeters, or define that as 6 millimeters. Where do I have to get this size though? That should be defined somewhere. I'm defining it in the other sketch. Don't think so. That's interesting. Okay, you are an outset. Got it. Deleting this causes this to not be fully constrained. That's Why? Why would that be? It's because this is set to the middle. Doesn't make any sense. I'm gonna delete this circle. Okay, fine. Here's what we're going to do. We're going to project that. All right. D, 6 millimeters. Face rectangle offset H. Got it. Now, I don't remember if I offset the inner one or the outer one. 52 millimeters. 54 millimeters. Okay, well, why is it over constrained? Okay, there, 54 millimeters. Fusion, you're weird sometimes. All right, so this is not 2 millimeters for that. Okay, so this is where the circle goes. We're going to put that I large, radius, diameter, large, cutout diameter. There we go. All right. Up. There we go. Offset vertical. Thank you. All right. Good. Now, actually, delete that. Wobble, wobble, wobble. All right. Where does this eye end up? Roughly here. Is that the diameter I want for it? Unclear. Kind of looking over at the picture on the other side when I should pop it up over here. All right. Looking at my sketch. Not my sketch. Okay. Does seem like the lens goes down to the lens. Sorry. The lens goes to this panel line, more or less. And oops, need that. Actually, yeah, the lens sits pretty much between these panel lines. Right there and there. That distance is 54 millimeters. Dun, 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 dun. All right. So we're going to center on that 54 millimeter circle, which will be situated roughly here. I don't actually want it to join to that one, thanks. Since I'm now defining all of these sizes, I don't actually need this particular point. Delete. Delete. Hello, sketch point. Delete. Delete. I'm looking at the wrong sketch, probably. Okay. Okay. So this should be 2 millimeters. 2. All right. That puts the lens diameter aligned with these panel lines here. And this bit is the surround. So I need. Let me look at my sketch, my picture here. It's a couple of millimeters out from the lens, looks like. Like, I don't know, 3, 4. All right, so this will be 58. Okay, that's the inside. If you're looking at the sketch over here, okay, on the sketch we have the lens, and then we have the inside of the surrounding bezel thing. That circle is the front of the bezel, I guess. All right, I'm gonna make this a construction sketch because I'm not sure I'm going to use it, but it is defining the larger circle out here. This one. Right, then I need another circle. Actually, I'm just going to use an outset for these. So let's do this one. There's what, 4? No. 2. Oh, there we go. Okay, and then an outset. That's 2, so we want like 3. 3. Okay, that looks like the very front face of that bezel. Okay, and then we want somewhere between this circle and this circle, probably aligned with. Actually, it's not aligned with much of anything. It's kind of halfway between here and here. So we're going to put another outset on this thing. We're going to put it out like there. Does it even make sense? Yeah, I guess it makes sense. I look at it. Yeah. Part of it is that this panel line, these panel lines are probably too big. What is this dimension? D326. Okay. D326, then plus 2, plus 3. Would you let go of the stupid dimension? Thank you. 3. Cease. All right. So then we need to go out again. See, see outset from here. 8. How does that look? Let go. Thanks. Okay. All right. Continuing. If you're wondering, if you're a VOD watcher, I'm listening to the Subnautica soundtrack. So, if you hear me singing along, that's what I'm singing to. Okay. Maybe this should be a little larger in diameter. 9. Might be good. Okay. I should probably define these circles on a different sketch because this is going to get annoying right in here. This stuff is going to get annoying. All this. So, but in the meantime, let's see, 54,239 2 millimeters from this point. Point is the center of this circle. It's the center of this diagonal line. Got it. Here's sketch. Wait on Fusion to catch up. It's dark in here, so it's not helping me to not be sleepy. I may take a nap here in a bit. I'm sitting here waiting on Fusion. It's done. All right. So, sketch. Head side details. Face details. And let's back all the way up to here. That's where the face details sketch is. I'm going to mess some things up if I change too much here. Do 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 do. So it's 2, 3, 9. Okay, that circle. I'm not actually defining anything from that circle. Just using the diameter to define things. Okay, new sketch, please. I could define the sketch on the actual part, but actually no, I can't because it's defined later. All right. Bonk. I need to project the center point. All right, C. There's a D326. 54 millimeters. Okay. We need an outset of 2 millimeters. 2 millimeters. I said it was 58. It's 2 millimeters on each side, so total 4 is 58. Added to the radius, or the diameter of the circle. It's 2 millimeters in radius, plus 54 in diameter. All right, and then another one that's 3. That would make it 60. Yes, confirm. 60 millimeters. Like, go. Okay. C. So no, not a C. This is either outset 9 millimeters. Fusion also doesn't let you do offsets from offsets. So I can't do 2 millimeters, then another 1 millimeter, and then another 4 millimeters. Yeah. A bit annoying. All right, now I can look at this bit. Good. It works. Where did I find? Wait. Dummy. I'm a dummy. I define these right on. Disable. Right on the point. It's not what I wanted at all. Okay. Let me get the point again. Okay, L. Keep going now. L 2 millimeters. And make that a construction line, and then all of these are going to be all of these, at least this one is going to be on this point. Hello? Oh, are they gonna be circles to each other? Okay, fine. Whatever. Let's do this. Over constrained. What are you talking about? There. Face. Face details. Let's turn off the others. Dum ba dum ba dum bum bum bum. All right. Well, I surround. I don't know. Call it something like that. Currently, I'm not placing that anywhere in particular. What is the distance between this point and this? 10 millimeters. All right. Oh, it's using an equation, which is the diameter of the circle. Okay, it's fine. We'll leave it then. All right. So I got this complicated bunch of circles. Swikles. Wait. Seriously, I defined this back here. I could have defined it there. All right. Redefine sketch plane. What plane are you on, sir? None of these. What body exists? I was not paying attention and did not define it in the correct place. One of these is where you are defined, so find out which one it is. This one. The hell? Okay. Sure. There we go. That's correct. All right, define it as a sketch plane. Since I'm projecting that and everything else is based on that, that's why it updated. Okay. I'm out of the sketches. Now we go to here. Turn off the construction plane, please. Okay. All right. I'm going to be back shortly. Take a short break. Enjoy the music. I'm back. Okie dokie. Okay, so this is a sketch that defines the stuff. I haven't actually fully defined that feature yet. I haven't put the one in the top up at all. Hmm. Let's see how I want to do this. That's the door. Rear details, side details, head side. Okay. We want the head center. We want to turn on the bodies. Turn off this stuff. Turn on the head center. So that's what we're working with. Hum, 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 hum. Just trying to think of the best way to go about this. Face details. No. Nice surround. Let's try. Bring off the bit here. Turn off these. This, and this. That's what we want. We can turn these back on. And turn on the head center. Alright, so when did I define these panels? Actually, before I go doing that. Panels. Is it there? But actually, when I did extrude the main part. Okay. Okay. None of that. There we go. And eventually, there it is. Rename base panel lines. All right, it's that one. So before we do that, we want to get the circle. I don't really need the whole thing, but I'm going to do it anyway. All right, E from profile plane. No, I want it from object, which is this object. And then I want it to go back to this object. And I want to join like so. Let's test this out. All right, this one I need a chamfer. Can't get much of a chamfer, can I? Okay, I think that needs to be wider. Rename extrude eye cylinder question mark. We'll call it cylinder. Why not? Okay, now this one chamfered here, but I really need the rest of the surround. Look at this. I can almost do these in two separate operations. Might be the best idea. But let's go back here. Turn off that one and that one. All right, where's that feature? That is in face. Oh, 81.9. Go with 82. Oh, 83. Maybe even 84. Okay, let's look at that. All right. Okay, we need zoom functions are weird. Okay. All right, now we can edit it. There we go. Also, it doesn't have to be an equal distance. It can actually be higher. Let me look at my concept here. Although, it might actually be close to correct. Okay, that's good. We're thinking. It goes all the way almost to the thing. Good. Sketch. Did I not name this already? Yeah, spell. Wonder. Okay. Have a look here. Up. Things seem okay. Dropped a couple more frames, but nothing too major. Bit peckish. All right. Base. All right, and concept. Now I can't do that the way I was thinking. The way I was thinking was that the contour of the eye, the outer eye, the orange bit on the top, where it's curved, I have to blend down. I mean, I could. Yeah, things on this don't really line up too well. So, for example, what I said was All right. That the black lens on this eye is centered on this panel. This panel. The black lens is centered on this panel. Then it's like the bottom of the surround, the bezel, is lined up roughly with this, which is fine. Maybe it does make sense. Let me look. The top of the bezel, however, the bottom of the bezel is lined up like right here. Bottom of the bezel is lined up here. And the top is way up here somewhere. Let me go in and look at this. Okay, well, the actual bezel thing is just going to be this line. Yep, that line. And we want the other one up there. Actually, that's not too far off. Yeah, the circle is not too far off. It needs to be probably a little bit wider. How did this get so wide? The bezel do that? Or the chamfer do that? It did. It's not supposed to widen that. Okay. Basically what I need really to do is take this shape, where the chamfer is, and actually make a conical shape, right, that actually intersects with this. And then do the same thing here, but a different cone. Bleh, bleh. Not sure. My brain's fuzzy. How long have I been going? 2 hours and 18 minutes. A bit less, maybe 2 hours. I hate to stop now because I haven't actually done that much, but I am tired. All right. I think I might call it for the moment. I might be back at some point. Not too long from now. But I might not. We'll see. All right. Well, let me... yeah, I think I'll call it for the time being. I'm gonna take a break and rest for a bit, and then I might be back, but I'm doing something later this evening, so I might. Depends on when I finish resting. All right. Talk to you later. Bye.